Now we will start with the second part, which is about the behavior of the waves. Here, guys, we talk about reflection and transmission, but we will not ask about them directly. It will be a base for another topic. هلا reflection is the change in the direction of the wavefront, صح? At interfere between two media. يعني when the waves meet another media, it will be reflected. So the wavefronts return into the medium from which it's originated. هلا I think all of you familiar with these things. In reflection, regularly انه wavelength does not change, frequency does not change, speed does not change. هلا amplitude changes according if there's an absorption or not. Okay, or if there's an absorption or transmission. Okay, if there's a transmission معناته لا في change. تمام، يعني no transmission or no absorption. هلا اللي بيهمني الفيز difference depends on the boundary. إذا كان عندنا reflection from hard boundary معناته هذا إيش؟ it will be reflected anti-phase. If there's a soft boundary, it's reflected what? In phase. Like this. This can represent the hard boundary. Look, the wave is reflected anti-phase or 180. This can represent the soft boundary. Okay. So if this boundary is hard, this is anti-phase reflection. If the boundary is soft, this is in-phase reflection. Hello, we talk about not reflection, sorry, transmission. Transmission, guys, is taking place when waves travel from medium to what? Another medium. Medium to another medium. Here, in this transmission, wavelength will change. Frequency always does not change. Speed will change, will amplitude as well may change accordingly. Look to this. Here we have a pulse. Is it transmitting from less dense to more dense? This is before. This is what? After. Look here, guys. Since this is a hard boundary, it will be reflected antiphase. Okay? Partially reflected or partially transmitted. Look, guys, to the transmitted pulse. It has less wavelength than the incident. Right? It has less wavelength than what? The incident, which means that the wave travels slower in this dense medium. Okay, and the height of the pulse or the amplitude in the dense medium definitely will be less than the height of the pulse in a less dense medium. Here the opposite, the wave was moving in more dense medium, then it's traveling or it will travel through a less dense medium. Guys, look to this is the incident wave length, let's say. Look to the wavelength here, guys. Increases because it's now transmitting through a less dense medium, so the speed also increases. Look to the reflected pulse, guys. Reflected pulse had a soft boundary, right? So reflected pulse is in phase. And the height of the pulse in the less dense medium is more than the height of the pulse in more dense medium or a denser medium. Guys, this is a base thing for, let's say, later on اللي هو رح نحكي عنه standing waves. هلا let's talk about diffraction. Diffraction is the spreading out of the waves as they pass through a gap or by an obstacle, forming geometric what? Shadow. If you remember, when the waves meet an obstacle, a gap or something like this is from the O level, they may spread out. They may what? Spread out. Let's talk about the diffraction. What is the diffraction? Diffraction, guys, which is commonly asked about the definition, it's the spreading out of waves as they pass through a gap or obstacle, forming geometric shadow. Draw the diffraction pattern for the following cases. Hello, guys, I think you have to, I would like to remind you by this. Diffraction depends on what? Depends on the size of the gap or obstacle compared with wavelength. Compared with the wavelength. If I have like this, if I have waves, these are the waves, incident waves. This is the gap or obstacle. If the way here, if the size of the gap is greater than the wavelength, as what you see here, here we will have less diffraction. Here we will have what? Less diffraction. Okay, look here. Here the waves will continue in this region, the waves will continue in a straight line. Beyond the edge, look, beyond these edges, the waves start spreading out, or part of the wave is spreading out. This is called the geometric shadow or shadow. Here, guys, we will observe shadow. Beside what? Beyond you might be asked to draw the diffraction like this. Well, one question in 2008 only about this. Otherwise, we don't have any question like this. Okay. So how will I draw this? Okay, guys. First of all, I have to measure the wavelength. The wavelength, it's the distance between what? Between these two wavefronts. This is the wavelength. Here, the distance is 0.7, if you see. Okay. Wavelength here is 0.7. Okay, according to my ruler. It's very obvious that the size of the gap is greater than the wavelength. So how will I draw the diffracted wavefronts? Here, guys, first of all, I have to draw a line. What I will do now, around 15 degrees like this. This is a dashed line. From other side also same thing, 15. This is just an approximate thing, guys. It's not a theory or something scientific. Then, look what I do now. First of all, I will draw the first wave at the edge. Okay, at the edge of the gap. then using the same wavelength, I would draw the diffracted waves. 0.7, 0.7, 0.7. 3 waves are enough. Draw plane waves. They must be separated equally. Then beyond the edges, I have to draw what? Normal curved parts or a diffracted part. Okay, guys? Now, if the size of the wavelength is equivalent to the size of the gap, like this one, I have to draw a diffracted wave fronts. طبعا here I have to use compass, guys. Here I have to use what compass? I don't have compass. But you have to separate the waves equally, also the same thing. And here 0.7 from this point to this point, 0.7 from this point to this point, 0.7 from this point to this point, what? 0.7. I may use the compass to, okay, they should be separated equally. And in order to demonstrate the diffraction wave fronts, we have to use what? Ripple tank. This is the ripple tank. Here, guys, I will use a plane pedal like this in order to make plane wave fronts, right? These plane wave fronts face what? Gap like this, so they diffracted in a circular shape. If you are asked to do this, or probably you might be asked to set up an experiment to demonstrate the diffraction waves, you have to draw one like this. You have to draw here that we will have a screen. Here we have a light. This is a generator or wave generator. And so on. A ripple tank can be used to show the diffraction. Plane waves are generated using vibrating bar and move towards the gap of the barrier. Where the ripples strike the barrier, they are reflected back and diffracted. Where they arrive الجاب يعني إذا بوصلوا للبارير هاد waves when they reach هذا barrier and this barrier they will reflected back. When they reach the gap they will diffract. Okay. Now if I change the size of the gap, I will observe what? I will observe the diffraction pattern of the waves like this, and like this. Okay, guys? Any question about the diffraction? Okay. Now, we will define something totally different, which is called superposition principle. For superposition principle, guys, it depends, or this concept is taken per consideration when the wave meet or overlap. Let's say I have two waves that meet, at this position where they meet, what will happen? For each point, the resultant displacement is the vector sum of the individual displacements of the waves. What does this mean? Here, guys, we have two waves, the blue one and the green one. They meet. When they meet, guys, they will form the red one, this one, like this. At each position here in this wave, at each position, the displacement of the resultant wave here is the sum of the displacement of, listen to me, guys, displacement of the red wave is the sum of displacement of the green and displacement of the blue one. So if I add the displacements at each position or at each moment, I will get red one. Let me show you something very quick here. طلعوا معي هون.
Okay.
Here, guys, we have a position. We have displacement for first wave. We have displacement for what? For the second wave. Finally, this is the resultant. Okay. So at zero position, the displacement of the two waves is 0. So resultant displacement is 0. At block 1 or at position 1, 0.8 to 2.8, 1.5, 0, 1.5, 2.2, here minus 2. The addition of that, I will get 0.2. 2.8 plus 0 ايش بيعطيني 2.8. If I continue here, 3.3 plus 2 بيعطيني 5.5 and so on. So I added here, guys, what I did actually, I added the displacement of wave 1 to the displacement of wave 2. I got the total displacement of the resultant wave. يعني هون again, guys, I know we have two waves. These two waves meet. As a result of this meeting, or overlapping, or interfere later on, we will call it, their displacements are add up. يعني I will add their displacement. Here, guys, I added their displacement. يعني 3.9 plus -2, 1.9. Let me show you something graphically. طبعا here, after we have finishing drawing, finishing adding resultant waves, here I ask you, or if you, يعني, I want to ask you this, to draw the first wave, to draw the second wave, and to draw the resultant. الفيز أو superposition principle depends on these four things: phase difference, amplitude, frequency, and polarization, right? Let me show you this. Here I have here two waves. They meet, wave X and wave W. What I want now to draw, I want to draw the resultant wave as they meet. Here, guys, I will consider different positions randomly. This one, this position. I may take also this position, this position, this position, this one, something randomly, but I want to show you something. Okay, here I will add their displacements. For each point, I will add their displacement. Here in this position, guys, the displacement for wave x is 0. The displacement for wave w 1, 2, 3, 4, 5, 5 point something. So 0 plus 5.5, let's say 5.5. So resultant displacement, guys, the resultant displacement will have the crosses that I will add now in a red, or red crosses. Here I have two displacements here. Okay, displacement from wave 1 or displacement from wave 2. 1, 2, 3, 4, 5, 6, 7 approximately. So 7 from wave x or 7 from wave y, so total is 14. So resultant displacement will have, or resultant wave will have a resultant displacement in this position. Let's take this point. Here the displacement is 1, 2, 3, 4, 4.5. Here 5, 6, 7, 8, 9, 10. يعني here 10, here 10, here 4.5, so it will be 14.5. Here 14, here 14.5. If I take this point, here 0 plus this point, صح, which is 8.5. And here the displacement of wave W 8.5, the displacement of wave X is 0. So the resultant is 8.5. Here, guys, we have two displacements in this position. Let me take another position to show you something. This one also. I may take this position. This position, بالله, pay attention. Here for wave W, it's -2, right? For wave W, -2. For wave X, 1, 2, 3, 4, 5, 6, 6.5. 6.5 plus minus 2, 4.5. So resultant راح تكون هون. Okay? Here, in this position, guys, this one, here -4, here +4, or +4 or -4. So resultant كم? 0. In this position, 0x و 7, -7 طبعا, it will be here, and so on, guys, like this. So I have to connect the points now. This is the shape of the waves. The one that I draw here is the resultant wave of these two waves when they meet or combined. Any question? Here, guys, I have two waves. I want to add them. I'll start from here. 0, 0, right? Okay. If I consider point here, the position is around 0.08 or 0.7. Here, the position is around 0.15, صح? So 0.08 و 0.15 راح يكون 0.23. هاي resultant هون بدها تكون، صح؟ عند هاي البوينت 0.1 و 0.2 راح يعطيني 0.3. at this point هاي approximately يمكن 0.7 or خدتك arbitrary points 0.7 let's say صح 0.7 وعلى نفس position 0.27 or something like this, so it will be 0.34, right? Here at this point 0 0.3 0.3. At this point, look here guys, this is negative 0.8 صح, negative 0.08, here at the same position 0.27, right? 0.27 I think. So if I subtract them around 0.20, something like this, just to simplify stuff. At B, here at this point, 0.2 or negative 0.1, so it's here 0 and so on. So I may draw the wave like this. And so on. This is the shape of the combined wave or resultant wave. Okay? A path difference. Guys, the path difference, it's from its definition, it's the difference between two paths where the two waves travel. Since we are talking about waves, guys, this path difference will be considered just a moment, guys. Okay. Let's consider here that we have two sources. Source at A, source at B. The waves here, guys, from A are diffracted in all directions. The waves at B are diffracted in all directions. So at P here, we will have waves reaches from slit S, or from A, sorry. We have waves meet from slit B or source B. And كأن عندي two sources. These sources generate waves in all directions. So at P, two waves meet. At P, two waves meet, or several waves meet from A and B. Now, what is meant by path difference? I measured A, P by ruler حتى even, و B, P. I found here, guys, that the both have 12 centimeters. So the path difference at P is what? 0. 12 minus 12. Okay, 12 minus 12. Since we are talking about waves, guys, I have to write always the path difference in wavelength. Diamond, I have to write it in a wave or proportional to the wavelength. In order to write this, I divided it by the wavelength. Here the wavelength is given, which is 1.3. I divided this by 1.3. I divided the real path difference by 1.3. So the path difference is what? 0 lambda. And here there is no path difference. If I consider R, guys, at R, Here at R, we have waves are coming from A towards R. Waves are coming from B towards R. So here the path difference, guys, I may consider like this. A R minus BR. I'm an absolute value. Okay. Guys, it's easy يعني ما في شيء عمر حبيبي. هو بس الكونسبت وين انه we have to measure the path difference. يعني انا عندي هون source A بيعطيني waves وsource B بيعطيني waves. هدول الwaves they propagate until they reach P until they reach what? R. الباث difference هذا path اللي هو AP صح؟ وهذا الباث اللي هو ايش؟ BP. تمام؟ I found the difference between them. هاي I measured it يعني هذا 12 وهذا 12 فالباث difference راح يكون كم؟ 0. طلع هلا احنا عندنا ناخذ at point R. هلا at point R guys we have two waves meet خلينا let's say to simplify stuff. Waves are coming from A or two sets of waves خلينا نقول. Waves are coming from A to R. Waves are coming from B where to R. Okay? Measure the path AR ايوه و measure the path what BR using a ruler. AR I found it before. It's a 12.6 12.5 sorry. Okay. طيب wait a second لأنه علم. Okay guys. He approximately had تفرجوا هذا 12.55 minus 11.9 يعني I found these results guys using array ايش using a ruler. This will be 0.65. Okay. Okay guys, this is the path difference in centimeters. This is the path difference in centimeter. So since we are talking about what waves, we have to write always the path difference in terms of lambda. In other words guys, هذا الباث difference how many lambda يعني قديش في lambda أو contains قديش في lambda. to find this شو رحت عملت أنا I divided the actual path difference على wavelength. تمام actual path difference اللي هو 0.65 على wavelength. تمام فالباث difference in terms of lambda يعني كم قد ايه الباث difference بين الويف of A والwave of B at BR هو half wavelength. Any question about that? طيب what does this mean? What is a result of that? يعني شو راح يطلع معي هون؟ تفرجوا معي. I will show you guys now the effect of this path difference. ركزوا معي. Now I will show you the effect of the path difference. Okay, anyway here ما راح تكون كتير accurate بس anyway. هلا I will divide this path to wavelengths. I will show you that. I will consider each 1 centimeter here على الرولر تاعتي أو each unit 1 wavelength. Each unit 1 wavelength. I will show you that. Guys, I'm currently now, or I will draw now the waves to show you the effect of this path difference. Okay, guys, this is the first wave. This is the second wave, third wave, fourth wave, fifth wave, sixth wave, seventh, eighth. Okay. Now the waves that are coming from B towards P, 1, 2, 3, 4, 5, 6, 7, 8. Guys, I want to show you something here. When these two waves meet, they meet trough at P مع ايش trough. يعني let's say انه هذا الامبليتيود نيجاتيف 3 وهذا نيجاتيف 3. الريزلت شو راح تكون؟ نيجاتيف وات؟ 6. Clear? Okay, here guys they meet a trough with trough. This is the interference or overlapping of the waves A P و B P. And I want to show you something. At R, what will happen? Similar wavelength, guys. I will do the same thing. One. هلا بدي اخذ من وين؟ من B ل R ومن A ل R ومن B ل R. shape. Okay, yes, fine. Here, one, two, three, 4, 5, 6, 7. جايز لاحظوا هون انه نص هاي جاي هون يعني half، يعني هون هدول كلهم complete wavelengths. اخر part هاي بدها تكون هون الويف الكومبليت، يعني هون بدها تكون تقريبا ايش half of the wave. Let me draw this. هاي wave، 2 waves، 3 waves، 4 waves، 5 waves، 6 waves، 7 waves، 8 waves, right? From B, 1, 2, 3, 4, 5, 6، 7. طلع هلا ايش راح يصير؟ طبعا هذا تيجي هيك يفترض وتكمل. احنا طبعا هذا البارت ما بدنا اياه لانه هذا beyond السكرين، احنا ما بدنا هذا. I want you to show something or I want to show you something. انه هذا البارت هذا الصغير اللي هون، هذا البارت مش complete wave اللي وصل هون، هذا نص الويف لأنه طلع هاي الويف، صح؟ هيك الويف. هذا approximately half of the wave. What does this mean here? When these two waves meet at R راح يكون عندنا crest اللي هو مثلا for example positive 3 مع trough اللي هو راح يكون كم؟ negative 3. يعني عند هاي البوينت guys according to my scale of drawing they meet crest مع trough. يعني قد ايه هون راح يكون resultant displacement؟ zero. يعني الامبليتيود هون zero. If the amplitude here zero guys معناته أنا I will see dark region here. ليه؟ لأنه if the amplitude is zero the intensity is zero. Here I will observe what? Brighter region. Right? Brighter region. ليه؟ لأنه الامبليتيود increased فالbrightness ايش؟ increased. لكم اياه اللي أنا عملته هون إنه أنا I show you اللي هو الكونسبت. شو فرق الباث ديفرنس؟ فرق الباث ديفرنس ببي إنه لما يكون الباث ديفرنس زيرو they meet two waves اللي جاية من A ومن B they meet crest مع crest أو trough مع trough. فبالأخير أعطاني إيش resultant larger amplitude. resultant اللي أعطاني إياها شو هي؟ larger amplitude. إذا الباث difference نفس الويفز ونفس السورس ونفس كل إشي بس عند R إيش الديفرنس بين P و R؟ at R في path difference مختلف لكل wave. فالpath difference as a result of different path difference they meet crest مع trough. فبالأخير شو أعطاني؟ زيرو. أعطاني إيش؟ زيرو. أنا قسمتهم لإيكوال lengths. مظبوط الويف. هاي من هون لهون نص الويف مش كل الويف. فأنا كملت عادي يعني لو بدي أكمل الويف فبتيجي هون crest مع trough. يعني إذا بدي أكمل الويف بكملها هيك صح؟ الريد 1. دي الكونسبت itself إنه الإفكت of path difference راح يعطيني different superposition. يعني مثلا هون التقوا كريست مع كريست لأنه الباث ديفرنس زيرو. هون التقوا تراف مع كريست لأنه الباث ديفرنس قديش طلع معي؟ هاف لامدا. تمام. الباث ديفرنس هون شو طلع معي؟ هاف لامدا. تمام. هلا ليتر رح نحكي عنه هذا بالتفصيل حسب الباث ديفرنس.
يعني حسب
this question in this way قسمت هذا هلا بدنا نشوف الباث ديفرنس والإفكت تاع هذا الإشي. جماعة إذا كان الباث ديفرنس هذا هو شايفينه S2P minus S1P. هي هون شايفين هذا S1P وهذا S2P. هذا باث تاع S1P وهذا باث S2P. if the difference between S1P S2P minus S1P أعطاني N lambda where N is integer. شو بصير بالامبليتيود؟ magnifying amplitude. يعني الامبليتيود بتصير يا دبل يا تريبل يا زي ما شفنا هون. إذا كان الفيز ديفرنس n plus half lambda. شو يعني n plus half lambda؟ يعني odd integer over 2. يعني إذا طلع معي أي path difference يعني if I divide the path actual path اللي أنا I measured it by ruler over the wavelength وأعطاني odd integer over 2. شو يعني odd integer over 2؟ يعني 1 over 2 3 over 2 5 over 2 7 over 2. إذا هذا الباث difference أعطاني هدول النمبرز معناته the waves meet what? Anti-phase. So eventually what will happen to the amplitudes? Are cancelled out زي ما شفنا وين؟ هون. هون لما حسبنا الباث difference وطلع معي half lambda at R صح؟ عند R طلع معي الباث difference كم؟ half lambda. I got what? They meet a crest with a trough وهذا causes that إيش less amplitude. As a result of that, I have إيش a dark region. Here at P, I have إيش a brighter region. So later on, also I would give you another example about this. So the path difference finally, but to sum up, guys, the path difference affects what? Interference or affect the overlapping of the waves. If the path difference is integer of lambda, يعني 1 lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda, 6 lambda, 7 lambda, if the two waves have the same frequency or same initial phase, they will meet either crest مع crest أو trough مع trough. Eventually I have magnified amplitude. If the path difference is half lambda, 3 over 2 lambda, 5 over 2 lambda, 7 over 2 lambda, or something like this, they will meet a crest مع trough, so the amplitudes will be cancelled out. So I have a darker region. I will have a darker region. Okay, guys? Any question about that? This is the effect of the path difference.